Hello, everyone. Welcome to today's webinar. We are excited to have you with us today. My name is Ryan Ingwerson with the National Laboratory of the Rockies, and I'm your Zoom host for today. Really excited on this talk on AI and digital tools and water research or water research with some wonderful experts here. Before we dive in, we do have a few housekeeping items to go over. Just really quick note that this meeting is being recorded and we will be posting it to the NAWI YouTube channel as soon as possible after the event. I will put that link in the chat so you can keep an eye out for that. We ask that you remain muted for the panel discussion just to cut down on background noise. We do want your questions and comments, and we will be opening up the floor to your questions. So be prepared for that. If you don't feel comfortable coming off microphone, you are welcome to use the chat feature and put your questions in there. If you do have questions and would like to come off mute, please raise your hand so we can make sure we don't have people speaking over each other. If you have audio issues, you can try connecting through your phone. If that doesn't work, or if you have any other technical issues, you can shoot us a chat and we will do our best to work through that with you. A couple other things.
Ryan, we can't do anything if they lose. I mean, we can sympathize with you. We can tell you there's a recording, but bandwidth is bandwidth. So
It's true.
yeah.
But we'll do the best we can. Couple of just really quick, join the NAWI network. We are always looking for more conversation and engagement with our audience. So follow us on LinkedIn. If after this talk you are interested in learning more about the NextGens and following their work, they have a LinkedIn there as well, and you can follow everything they're working on there. And I will put those links in the chat as well.
Yeah, Ryan, let me just say about LinkedIn. So one of the things we're pivoting to in 2026 is much more kind of like of our communication will be coming through LinkedIn. So just make sure that you are following National Alliance for Water Innovation, NAWI, and that'll be the place where you learn about stuff. And then we also have the NAWI Dispatch. So don't miss it. We got several ways to connect to you.
Thanks, Peter. And I think that's all for us. So I'll kick it over to Wajiha to introduce the webinar and our panel.
Thank you, Ryan. And hello, everyone, and welcome to today's NAWI NextGen webinar on AI and digital tools in water research. My name is Wajiha Tokir, and I'm part of NAWI NextGen Leadership Council. And on behalf of our NextGen team, I would really like to welcome you all. So before going into the introduction of our panelists, I would like to give an overview how this session will follow. So first of all, we will start with a moderated discussion about how AI and digital tools are making an impact in water industry. And it will be followed by a timed question and answer session. And you are most welcome. Although we have a specific time in time for question and answers, I would really appreciate if you guys have any questions and you can post it in our Q&A box. And if it felt very relevant to any of the questions or discussion going on at the moment, I will chip in those questions as well. So that's how it will follow. And now I would like to start with the introduction of our speakers. So first of all, we have Dr. Kate Newart, and she's an assistant professor of environmental engineering at Oregon State University. So Dr. Newart, can you briefly explain your current research work to our audience?
Sure. I previously was an engineer at a large wastewater treatment facility. And so I really do research at that higher technology readiness level of the deployment of AI technologies to address the gaps that we're observing between the technologies as they're developed, as they come out of the research labs, and what knowledge gaps still exist before we deploy them at full scale, and really addressing that set of questions at water and wastewater treatment facilities.
Sound good. Thank you so much, Dr. Kate. We are very excited to have you. And the next we have is in our panelist is Dr. Chris Willis, and currently he's working as a researcher at Oak Ridge National Laboratory. So, Dr. Willis, can you please tell us more about your work?
Sure. So my name is Chris Fillet. I started off in environmental engineering during my studies, and throughout my research, I rolled into data mining, sensors and control. And I'm gonna date myself, but it was a time before AI was cool. So I got the whole sort of hype experience of AI at end of the knots. Anyway, I primarily worked on wastewater treatment control for a while, including small-scale systems, large-scale systems. And since I arrived in the US about 6 years ago, I've expanded a bit and now work also on water production systems, particularly through NAWI, again, sensors and control, as well as manufacturing of additive manufacturing space, think large-scale 3D printers. Thank you.
Okay, sounds good. Thank you so much, Dr. Willis. And our last speaker is Dr. Adam Attia, and Dr. Attia is the principal investigator behind WaterTab, which is NAWI's flagship modeling platform for simulation, not just simulation, techno-economic simulation and optimization of different water treatment systems. So, Dr. Attia, can you explain more about your work and WaterTab specifically as well?
Sure. So hi, everyone. I'm Adam Attia. As was mentioned, I'm the lead for WaterTap development and application. WaterTap is basically an open source platform that's been funded through NAWI and the DOE over the last few years for process modeling, simulation, optimization, but most of all, techno-economic assessment, being able to evaluate novel technologies against each other, but not limited to novel technologies. I'd just say established and novel. So I've been a core developer of WaterTap since 2021. When I joined the team, I was recruited by Tim Bartholomew, who used to lead the project. And I am with NETL. I'm an NETL support contractor. NETL stands for National Energy Technology Laboratory. And yeah, my background is mainly in membrane desalination, flexible operation, and I did a lot of process modeling during my PhD at Columbia. I'm happy to be here.
So thank you so much, Dr. Attia. And in the end, I would like after the introduction, I would like to thank all our panelists for the introduction. Now let's start with our discussion. So first, one of the question which is very basic one is for let's say all the panelists, and it is like where do you see at the moment and where you can foresee how AI and digital tools are making impact in your area of work. So might be sensors, utilities, or techno-economic analysis. So where do you see it is at the moment, and how do you foresee it can make a greater impact? So anyone can go first.
I'll jump in. So what I think is changing is utilities are now starting to look more intensely at the data that they collect. They basically sit on large troves of data that historically they haven't really looked at. And I think AI tools and ML tools allow to do that and have reduced the barrier for utilities to basically extract information from the treasure trove that they have. And I think what that tends to reveal is certain inconsistencies in the data, certain challenges with the data. Some data is not stored in the right way or where it should be, or it's insulated or isolated from other data sources. So that desire to now explore AI tools and ML tools kind of leads to identification of some sore points in data management, sensor management, and the like. So where I think it will affect my work is there will be questions as to not so much about the AI, but how do we feed the AI with the right data efficiently without too much overhead, making sure that that data is the right sized and of the right quality to really make use of those tools.
Yeah, I agree. And like I have, as you mentioned data, this was in my mind as well to ask you, like how like you think AI at the moment is helping enough to control the noisy data, or like how do you think in your area of work in terms of sensors and everything, how do you deal with noisy data?
You're asking me, or I can go on? Yeah. So I think there's a bunch of standard tools that are readily available, going back to basic statistics. I think for people that are not doing anything right now, I would say let's start there. There's basic filtering techniques that are that any sensible statistician can point you to. The thing I would definitely warn against is reinventing the wheel. There's plenty of textbooks on how to deal with noisy data. What I would rather say is so noise in the classical sense, pure noise like you would hear on the radio if it's not tuned right, or on the TV if you think back on the 80s, 90s TVs. That kind of noise is relatively easy to deal with. I think what's a bit more difficult to deal with is things like calibration error, which are more systemic, meaning that every data point is affected the same way. Same for sensor drift. So if we take the broad category of sensor faults, then I would say there's some open questions there in that space. But noise in the narrow sense, I think is a solvable problem.
Okay, that's good. Thank you. And whoever want to go next.
I guess I could just jump in. I think the question was, how do we see AI and digital tools making an impact? I guess it's easier for me because my main work is developing a digital tool to impact the water sector. So I think through capabilities like those that WaterTap possesses, we can more fairly evaluate technologies, do risk reduction, accelerate the deployment of new technologies. We could help guide experimental campaigns through optimization. So there's model-based design of experiments that we can work into digital twin workflows, for example. This is something of interest on our team that we're trying to pursue. We haven't yet applied it, but this is something that has been applied in other areas of process systems engineering, I would say, within our sibling teams through the national laboratories. Predictive maintenance is something that can be enabled with these tools. But at a simpler level, I could look at Gen AI tools and say, wow, this could help me debug my models more quickly, or even develop new models more quickly to do mundane things that the rest of the team maybe wouldn't want to do right away. I think that's probably the lowest hanging fruit, right? Yet we have to be careful about that because we have to follow guidelines on the usage of Gen AI. But hopefully that day will come where we could deploy it in such a fashion.
All right. Okay.
I'll just quickly add, I think Chris, as far as the utility application, is spot on. The majority of utilities believe that AI will in the future be able to help them operate better. Now, I think folks are realizing that operating better doesn't necessarily mean that you have 20% chemical savings, but rather you operate more robustly and more resiliently, and that has additional value. The idea of having additional insight into the process as regulatory changes happen and you can maximize your existing infrastructure without additional add-ons. But that is still a very future thinking approach, and utilities that do see that as a, I've looked at my books, I cannot continue operating with the status quo financially, they have begun to do data management audits. So truly understanding where all of their data lives, how they can get it into a single place to talk to one another and actually leverage these models. Because when you deploy, you either have to be behind a firewall where you have access to a lot of instrumentation data, or you are offline on the business network and have access to all of the data. Now, that has really driven a lot of decision support tools to be developed that can operate on the business network that don't have direct control access, which I think is what we all think of and dream of when we think of, a digital twin controlled facility. But that being said, there's a lot of innovation I think that can happen, especially from students who are trying to find ways, creative ways to apply these new tools, machine learning tools, AI tools, computer science innovations, given the existing infrastructure limitations. And I think the more of those case studies that we can develop better business cases to drive more utilities to invest in better data management, better data quality for future deployments. But also to better understand how we can overcome some of these infrastructure limitations. Because once again, there's no consensus. Every utility is doing things differently. And so I think that is also a challenge that we face. So we are in, I would say, if we think of the exponential growth curve, we're still a little bit on the flat end. We are still trying to overcome some of those fundamental hurdles.
Okay, yeah. So based on what, since you have mentioned about different utility operations and full-scale utility operations, and they are using data management as well. So like, and you are working on it, on it as well. So maybe this question maybe with for both Dr. Kate Nawart and Dr. Willis as well. Like how do you see, like what is the most biggest, you can say, challenge you faced while you were deploying different machine learning models to full-scale utility operations? So for your case, like when you guys were working on it, so what were the challenges which you felt were the real world challenges?
I jumped on it the first time. Maybe Kate go first this time.
So besides simple infrastructure challenges, the biggest, I'd say number one, the data that engineers download directly from a data historian is likely not representative of how the data is going to look when it is deployed on site. So there's that data incongruity that will very much highlight if your model is anyway overfit almost immediately. Second to that is we forget that about, if you think about the distribution of your data, everything about below the 20th percentile and above the 80th percentile, your model is going to not fit very well. And so we deploy, and maybe we used historical data from the past, few years that may not represent what happens this spring or this summer. It might start even slow creeps outside of the previous model space. It just takes a few variables of those, a few predictor variables going outside that space to cause those errors to skyrocket. And so I think we need to remember that model development is a cycle that continues after deployment, and not to spend too much time on the forefront thinking you'll get the perfect model, deploy it, and walk away, because you do need to find a way to integrate this new data, to work with operations or engineers, whoever is the user, to help them turn this prediction or whatever information you're providing and give them an idea of how, even under uncertainty, they can still leverage this for improved performance over the status quo.
Mhm. Sounds good. So you mean we need to, with time, and once it's deployed, we need to continue uh, sort of training the models for the future events, because let's say for the climate and everything, it's changing, and it is becoming, with time, becoming less predictable, we can say. It is somehow, but still there are chances of anomaly as well. And what I understood from what you said is that it needs to be trained according to the newer circumstances.
Yes, but also recognize there's always going to be new circumstances. We know this is a fundamental limitation of AI. So one, not every problem should be an AI problem, right? Or
Yeah,
maybe think of hybridization approaches.
yeah.
We, for an example, found a limitation in a predictive model for struvite precipitation. We were trying to do chemical optimization of a full-scale struvite reactor. Well, instead of directly predicting the concentration of chemical adjustment, providing operations just a general recommendation of increase, stay the same, or decrease, you go from an accuracy of somewhere in the 60s fully deployed to an accuracy of 98%. And that also, as a decision support tool, is much more likely to have trust from operations staff than giving them a single number and asking them to trust that, because once again, your errors on the far end are going to be so far out of the realm of normal for them, it's less likely to be adopted. You already lack trust with operations in a lot of these spaces. So you're not just building existing trust, but you're trying to continue trust. So that's also an aspect of human-centered design that I know we think about it with conventional technologies, but how that is now integrated into AI technologies, I think is still a new frontier.
Sounds, yeah, I agree totally. Yeah, so yeah, it's not like just the AI or data-driven approaches. Hybrid approaches could be way more helpful in many cases. I agree.
If I
So
can
yeah,
support
please.
what Kate said, is that many plants are basically permanent construction sites. So the units are being taken out of operation into operation, and that means that the relevant data that you have access to build a model for, let's say, current operation can be quite limited in time, right? And again, to reiterate what Kate said, it means you need to update your model as you go in most cases. This is currently not automated yet, that you have an automatic reconfiguration of these models as you know, refurbish one unit or another, or add a unit or remove one, right? So I think that's a technical challenge. I think you were asking about technical challenge, but I also want to point out there's people challenges.
Yeah.
Management and operators might have different expectations of what the AI is supposed to do, how it will affect their daily routines. So it's important not to forget that. A little more practical also, if you use sensor data to build an AI model or a machine learning model, you hope that they're well calibrated. Where I've come in tricky situations is the people that calibrate the sensor trust the lab data and treat it as if it's perfect and without error. And then sometimes you learn, well, the sampling procedure or the sample that is taken to the lab may not be as representative as you want it to be, or something happens in the chain of custody between sampling and lab measurement. So this, in some cases, you need a little change of culture where you don't just say, I trust this source and I do not trust this other source of information. And that, again, has a lot to do with people and getting people together in the same room and on the same track.
Yeah, I agree with what like Dr. Willis mentioned, that people need to be, all the teams who are working on specific project needs to be on the same track, and there is always a chance of experimental error to some extent, since it's being performed by hands usually. So I guess it would be a common sort of practice to have some sort of error margins to the experimental values which are being put, I guess. Right?
Mhm.
Yeah, okay. So I guess before going into any other questions, so I will continue the questions as well. I think let's see some of the questions which we have in our Q&A box as well. So there is one question from Ali Reza, and he's curious to know how MLO, I don't know about it, I guess. So MLOP's procedures can be implemented for, I think it's WRFFs, then what can be the challenges and hurdlenecks? So I'm not sure. Ali Reza, can you say out loud what you're trying to ask?
Yes, sure. Hi, can you hear me?
Yeah, you can.
Yeah, thank you very much. Hello, everyone. Yes, so I was just curious from the last question and discussion that came up that so machine learning operations can really be helpful here in terms of how we want to operate the wastewater treatment plants. So I was just curious if you have any idea and what can be the challenges if we want to implement these from like the software implementation, hardware implementation specifically, if we want to do to use these machine learning models being developed specifically for wastewater treatment plants.
I can go in and Kate can probably support me. So we were in a joint project and we tested many machine learning models against each other or for different applications in one project, which was really unique that we were able to look at 5 different or 6 different uh, processes. And this was on wastewater treatment controls. And one thing we learned is that for each process or each case, we ended up with a different machine learning model. So I think that poses a challenge. It's a bit different than physical chemical modeling, where you can have a standard library of models that are broadly applicable. In this case, it seems you end up selecting a different model structure almost for every application. Um, that certainly can be challenged. Maybe there is a model structure that works for everyone in a machine learning model, that is. But I see that as a main challenge, is that for every different plant, every process unit, you have a different model with needs its own kind of maintenance. I think that sort of compounds the complexity of operation and control rather than simplifying it. So that I see as a challenge. It would be great if we can find sort of more unifying strategies. So I'll stop there.
I'll also add on, now mind you, I'm not an ML ops engineer by any sense of the word. Facilities are starting to hire folks that have data science backgrounds, but these are one-off positions. And sometimes they come from other industries and can help inform different way of doing things. But for the large part, we are still on the frontier of deciding what ML ops looks like for water and wastewater treatment, given the inability to put models behind a firewall. Now there are utilities like Hampton Roads Sanitation District that are creating basically DMZs where they can have some limited data transfer, but that is an incredibly highly skilled workforce at Hampton Roads that is not representative of the majority of facilities in the United States. And so thinking about, there are, and this is actually a great opportunity for startups, right? There's some startups working on putting these on edge devices, ML on edge devices, as a kind of way to get around this limitation of the data silos, the business network versus the control network, as Chris mentioned, each area is unique and has its own unique challenge, and not every optimization, I would say, function is going to be the same nor explicit. So it's not always about, minimizing error, but we talk about, when I talk to utilities, what are those challenge cases that you want to see the model behave in, those high flow events, those high load events, if a sensor goes out events. And so not every problem is going to be identical. Not every challenge is going to be identical. And so, yeah, I will echo Chris in that the homogenization of knowledge, I think it's still a very multidisciplinary and very broad collection of knowledge to get to the right model for an application, given everything else going on. And I do want to echo, Peter made a comment about modeling being a continuous activity, and that maybe being daunting for a lot of engineers and operations, once again, because they have limited staff to be able to maintain this. Those large facilities are doing homegrown AI models, which is awesome. But once again, limited staff, limited deployment, but they're slowly figuring out where they confront the biggest data quality issues. Those are the utilities that are actually tried to develop business-wide data governance operations. But medium and small facilities, they will continue to rely on consulting and contracting out for the development of these models, which will fundamentally need a different set of configurations or deployment options, and therefore modeling objectives, even if you're trying to address the same problem, which even gives you a bigger option of model selection to choose from. So Peter, I hope that answers your question.
Yeah, okay. So let's go more into water tap now. So I have a question for Dr. Adamatya, that how do you, or let's say we have talked about key data gaps, or if we have too much noisy and data, how does water tap look into it when we have, let's say, is it how do you take care of, let's say, noisy data, or what are the modeling gaps which you have seen in designing water treatment systems?
Okay.
And
Oh, go ahead. I'll let
so,
you finish.
like in terms of, let's say, you mentioned that digital twins hasn't been implemented on for desalination systems so far, right?
Yeah, so we're pretty early in the process of, water tap traditionally has focused on steady state process optimization over the last 4 or 5 years. And I'd say over the last few months, we've been transitioning to, stepping into dynamic modeling, dynamic optimization, which is a bit more challenging, and working towards digital twins. And just to be clear, when we say digital twins, we're not just talking about a digital model representing a physical system and no linkage in between. Anyone could have a model of a system, but we're just talking about the two-way communication between that physical system and model. So you're continuously updating the model with parameter estimation to retune the model and then spit out results that are that will either control the physical system or inform it in some way, right? With real-time monitoring. So we are pretty early in that process. I could say that right now, what we've noted, I mean, the main limitation from my perspective is access to the data, right? Setting up a stable data pipeline so that you have a continuous stream of data coming in, feeding into your model, that's the number one barrier for us right now. The modeling side, I mean, maybe we'll get to some of the challenges that Chris and Kate were talking about. We're not quite there yet, but I think from our perspective, getting that data pipeline in place is a challenge. Another thing we encountered with one of the NAWI pilots that we're trying to work with is that, we explained that we wanted to apply a full digital twin workflow where we could take in continuous data and then subsequently do optimal control on their physical system. And we were told, like, hey, we would never do that with a purely data-driven model. It has to have some sort of mechanistic model underneath. First principles modeling has to be in the works, right? And so it goes back to that note that we should strive for hybrid modeling, where we use first principles modeling as much as possible, combined with some data-driven relationships, right, that are worked into the model for the more uncertain aspects, right? The things that we don't know how to truly model mechanistically. Let's see. Another thing that I think can be challenging will be, so let's look at, let's say, an RO application. So predictive maintenance in the short term, maybe that can be doable, but predictive maintenance in the long term, I think could be a challenge, right? So predicting, the level of degradation in your membrane performance over months, how do you do that, right? Another thing that is of interest so far from some of our stakeholders is direct, detailed chemistry being incorporated into our process modeling. So essentially, we can optimize a flow sheet subject to, let's say, mineral scaling constraints. So I want to maximize the recovery of my RO system, without having gypsum scaling occur? What's the maximum water recovery I can achieve given this known feed water composition, right? So we could do that now in WaterTap, and we're working on ways to make that easier. One of the challenges, though, is that the data that we have available, it's really thermodynamic databases that we're working with. So you could get the saturation ratio of particular scalants, but you don't know kinetics, right? So sometimes we'll see like a long list of potential scalants, but some of them are not kinetically favorable. You know, they'd scale over geological timescales, and we don't care about those, right? So being able to tease out the short list could be a challenge. So I'm just thinking if we wanted to incorporate that into a digital twin workflow where we're providing some real-time estimation of the level of mineral scaling that's occurring in a process, or you know, predicting how the amount of solids that we can precipitate out if we wanted to do that. Doing that accurately would be, I'd say, a gap, but also high value from what we're seeing with our stakeholders. Did I skip anything? I think that's mostly what I had in mind.
Yeah, I think it's like I guess you very well summed up. Let's say challenges which can be faced in terms of less when we are doing process optimization point of view. And so what I felt like there is the data, there's let's say some sort of challenges with the data everywhere at all the levels or all the types of research we can say we are talking about right now. So is there any, you felt that the stakeholders or the industries you are working on, did you see any, did you saw them being a bit hesitant when it comes to adaptation of new technologies or new methods, or let's say machine learning approaches? Or because like for me, going all into let's say data driven approaches might I might be needing some convincing about it. So were you able to see anything that, or were they very open to whatever solutions you were throwing at them?
No, so I just want to reiterate the point that we're early in the process, but from what
Okay.
we've seen so far in our limited time working on this aspect is
Yeah.
that, you know, again, a purely data-driven model is not going to cut it for the people we're talking to. They want to have some mechanistic modeling underneath, augmented perhaps with data-driven relationships.
Both. Yeah.
Otherwise, it's too risky, right? They would never allow such a model to control their system. I mean, if you're going to give them real-time monitoring and estimation, that's a different story. But if you're talking about controlling the system,
Yeah.
that's risky. But I mean, really, I think another challenge for us is a lot of the data is proprietary, so people are like hesitant to share. That's the biggest problem. And another thing that we learned, I mean, I think we probably hypothesized this, but we put together a project support group to, you know, advise us along the way. And when I say us, I mean the WaterTap team. And the two main things they said we need to do for WaterTap is one, make it easier to use if you want to facilitate industry adoption. And two, have people trust in your predictions. So we need like validation data sets. So they want to see that we've taken real world data from real facilities and validated our model against those data. And that's something that's lacking. It's something that we're working on.
I'm going to jump on what Adam just said there about validation. So I've talked to folks at the NSF, for example, who say there have been, I mean, think about the last 10 years of publications in this area of machine learning applications for the water sector. And I feel like for a long time it was just open a textbook, hey, let's try this method on this thing, and this is novel contribution. But really, it wasn't like a systematic evaluation. And once again, once we went to scale, we saw there was a lot of behavior that nobody anticipated in simulation. And so I think a lot of funding agencies, when they say you need to validate this, they're not talking about a cross-validation schema in simulation. They're talking about put this on a network and see what it behaves like as a, I like the term digital shadow, right? It's there. It uses the data as it would. It makes a prediction, but it is not actively integrating with the control system in any way. And this is purely for understanding the behavior of your model in the wild. That is the gap of information that I think a lot of new science to be successful needs to begin to integrate so we can ask and answer those next generation questions.
So I have a sort of a follow-up question for all of you, which is since you are all collaborating and Dr. Willis is from National Lab, and then we have academia, and then Dr. Adamatia as well. So how can national labs, academia, and industry better collaborate to accelerate the digital innovation, like which is happening now, and how can we do it more in water area?
I'll jump on a thing. One thing that I find missing right now, and I think we'll need a sort of whole scale approach, is approaching water as as a holistic problem, right? So AI and ML, of course, is getting away with process controls, unit level controls, sometimes plant-wide control, but really to look at the system as a whole, because ultimately it's all the same water. This compartmentalization, I think, is a true challenge. So I think we need to build models that can work at that scale. We need to do integrating data sets across the fence, so to speak. But I think it also points to legislation and policy that hopefully uh, uh, academia, national labs, and the like can help inform legislators to basically set up policy frameworks that incentivize the use of this new technology rather than being restrictive. So permit violations is obviously for many plants. That's the one thing they care of. But if that's the only thing you take care of, then you shouldn't really use an AI for anything, right? So I think there's opportunities there to work in sync between let's say solution providers across the board and legislators, policymakers to set the stage for things to really work in that direction.
Okay, so doesn't yeah, please go ahead.
I guess I could just add from the water tap perspective, use open source platforms like WaterTap. We could all come together on an open source platform and contribute in different ways, right? So maybe the national labs help maintain that software and keep it alive over the years, while academics contribute new models and new technology representations, right? And industry contributes by providing data sets to validate against. But we just need some sort of framework that will facilitate that, I think. And I don't have the answer to that, but how do we get industry to maybe anonymize data and share these data sets for wide scale validation? But I think it all centers around leveraging open source platforms and also just making these tools, like if you want to accelerate innovation, you need people to adopt it. And if you want people to adopt it, you have to make it easier for everyone to use. So that's the main feedback we're getting for WaterTap and industry adoption. It has to be easier to use. And so that's like the top of the list for us.
Okay. So I think now we can open the
Can I add one point?
yeah,
Sorry,
yes, please.
I think another thing we can definitely do is prepare the future workforce. I'm sure you as NextGens have an open ear to that. But historically, DOE has financed initiatives in that direction. I think there's plenty of room for that. So, like Kate mentioned, who's going to maintain all these machine learning models? Right now, there's a few select positions, like you mentioned, that basically are meant for PhD graduates. But I think if we want to do this at scale, then we will need bachelors in environmental engineering that can do that sort of maintenance. They might not come up with the fanciest, most recent model, but they should be able to use it and deploy it, especially if we also want to look at smaller scale plants and not just the big ones. So I'm going to point that out as something to do for national labs, academia, and maybe through industrial partnerships as well.
I'll echo what Chris said. So, as much as it probably doesn't feel like it, I promise you, your academic program is talking about how they are going to integrate data science better into the existing undergraduate and graduate curriculums. I think we don't know the best way to do it yet, right? Given the existing faculty members likely do not have the expertise to integrate a Python project in their groundwater modeling, class tomorrow. So it's a balance of support. It's a balance of how do you scaffold those types of programs, right? Because if you just see it once, like you're currently seeing in, whatever coding requirement you have, and then never reinforced, then that's not helpful. But your academic program is talking about how to do this, but in the interim, and I can advocate this. I was a self-taught data scientist. I took C++ as a sophomore in college, and that was the only formal data science, that's the only formal coding education that I had. And this was obviously in the days pre, actually a master's of data science being an option. So I would say, especially given the nuances of the problems and data that are generated by engineered environmental systems, and that you are likely an expert in the data that is going to be generated and the types of problems that are pertinent. I think that is a perfect perspective and time to look for specific methods that can help address your specific problems, because you do not need to learn all of non-parametric statistics to address your problem today. And the next pilot you work on, you'll learn more and learn more and learn more. But I'm a huge advocate in improving the data science literacy of traditionally trained environmental engineers, or mechanical engineers, or whatever your background might be, because we need to be able to communicate more effectively with the computer scientists, with the statisticians, to accelerate that problem formulation, solution, deployment, modification pipeline. So self-teach, don't be afraid, is I think the status quo, with the long-term goal being now we have a workforce that's been developed across specialties, across education levels, so that we're all speaking a common language and we can better put expertise where it needs to be. For example, Chris and I work on projects because I know him and his team at Oak Ridge have a set of expertise that my students do not have. And this is not only a great opportunity to build a multidisciplinary project, but a great opportunity for knowledge transfer, and professional development. So as far as speaking back to the academia and national lab partnership.
Yeah. Yeah, please
Oh,
go ahead.
I mean, since we're talking about this, I'll just throw in there that, there's a lot of buzz with Gen AI, right? And I've had
Yeah.
people come to me saying, hey, I vibe coded this model in WaterTap, and just tell me if it's any good. And people are all excited, like, wow, they did this complex model without knowing WaterTap at all. And I'm not gonna, I don't want to say that there's no value there's immense value in Gen AI and all that, sure. But if you don't have the subject matter expertise to rule out what's fabricated versus real, maybe you'll be in trouble, right? So, I've gone through some of these examples, these vibe coded examples, and they seem to work. But then when you dig deep and you know what you're doing, you'll see that, oh, they just didn't solve the problem at all. It looks as if it was solved, but it wasn't. So, I mean, all that just to say, like, there's a lot of hype right now, but I think your subject matter expertise will count more than anything. And then, like Kate was saying, being able to speak the language of the computer scientists as well, and things like that will be helpful. I'll also say, in terms of workforce development, we have this thing called the Water Tap Academy, where we're teaching practitioners how to use water tap. So there's an opportunity for you if you're interested. I would recommend having some fundamental knowledge in computational programming. That is almost a necessity for the Water Tap Academy. But I think if you could combine your subject matter expertise as it regards to water treatment with computational science to some degree, you'd be in a good place.
Yeah, I think Adam, you have dropped the link for Water Academy as well, or
Well, you know what? I could drop a link.
yeah.
So we do have a GitHub repository. Right now, we're concluding our first cohort program this Friday, and we do have a GitHub repository where we share materials. I could drop a link to that
Yeah.
in the chat. But I did drop earlier some links to the water tap code base, which is on GitHub, as well as the technical documentation that we have, and a couple other links.
Okay. So I think we are really short on time right now. So we did talk about some of the questions in Q&A, but anyone else who have questions, please raise your hand and they can go ahead with it.
I'm actually gonna pick and choose a little bit from the comment section, if we don't mind, because I think we have some good ones here. The first being from Ron Swanson about open source platforms and the kind of debate there. As an academic, I'm also going to advocate for the open source. I think when we publish our work, we should also be publishing the models that were underlying it. It's incredibly frustrating to go to conferences, see this case study beautifully displayed and have no insight into the pipeline that contributed towards it, but also what was the learning curve like to get to that final model, right? When you say I chose this specific method to overcome this challenge, I know you tried 10 other methods to overcome it. What worked and what didn't, and understanding the why. And mind you, that's probably an academic question and less so of a consulting question when they're conveying this, but I think we need more transparency in order to come to that holistic understanding of what works well modeling wise and what doesn't, because we still don't have that kind of doctrine established. Not sure if we ever will, but if for those that are kind of in that mantra. But I don't know if Adam or Chris have any other thoughts on open source versus proprietary technologies in this area.
Yeah. Do you have, Dr. Adam can.
I think it's a tough question because we're still trying to answer this question. But I think there are ways in which we could come up with data management procedures where our industry partners feel secure in the fact that we could anonymize the data, strip out any PII and things like that, to reassure them that their secrets won't be leaked. But maybe there's I look at this other tool from NREL called the System Advisor model. I mean, it's really on renewable power systems and everything, but the way they stayed afloat, from what I understand, is they had companies invest in their software, and they would invest because they'd have the opportunity to put their data into the database of SAM, which many people are using. And so the vendors get, exposure to their products, right? Exposure is given to, people who are using the software. So I've been thinking about whether we could do something similar for water tap, right? Can we create an incentive for industry vendors or collaborators to sort of openly certain data that could be of use, with the carrot being that, hey, a lot of people are using this platform. It's going to give you exposure to your product. But other than that, I don't have a great answer. Chris, I saw you unmuted.
Well, yeah, we should mention that just because you use open software does not mean that if you have your own proprietary model for your proprietary technology, you can still integrate that in your own local version of WaterTap or any other open source software, right? So it doesn't prevent you. It's just then, in that case, of course, you're personally or as a company responsible for the quality of that model at that time. So I think it's a bit of a trade-off then, and each company can decide on their own how much they want to release. But I very much appreciate the idea of, what are you really selling, the model or the technology? If it's the technology that you're selling, you would want the model to be out there and available for design purposes,
And I think Chris's point gets to Jacob's question about the role of the private sector versus research institution in the development of these technologies. And I would say many of the startups that I've seen, they are selling a pipeline as the package, right? They have many, many models, many of which are open source, but it is the collection of them together, it is the maintenance of them for the utility that serves as the product that they're selling. And a lot of times it's in a new way. Like I mentioned, the edge device option, agentic AI, the combination of models with LLMs, right? So these are just some examples of some of the startups that I've seen recently come out and be very successful that integrate open source models in a new way that becomes a proprietary technology for a startup. Other thoughts from Adam or Chris?
That's good.
I just wanted to circle back to what Chris was saying. I interpreted the question differently. I just want to establish the fact that we do have workflows in place when we're dealing with a company where we keep everything confidential, proprietary. That does not go up on the open source repo. And so we do have workflows in place for that. What I was speaking to was more like, if we want to have validation data sets and things of that nature, that is open source, that's the barrier that I'm sort of struggling with. In my mind. But, yeah.
No, I think it's about time to conclude our session. And I would really like to thank our speakers, and it was a very fruitful discussion. And I would like to thank our audience as well. And I hope that they were able to learn a lot from our speakers. And now I would like to ask Ron, who is the chair of NAWI NextGen right now, to give us a brief overview of NAWI NextGen and what we are working right now.
Thanks, Wajia.
Yeah.
And hello, everyone. And once again, thank you, Adam. Thank you, Dr. Villes, and thank you, Dr. Newhart, especially for picking my question out of all the spectacular questions that were up there. I appreciate it greatly. I am, as Wajia said, I am current chair of our NextGen committee. So this is my quick little plug of how friggin' awesome we are. And anyone and everyone that's on this group right now, please consider becoming more active. NextGen specifically is here to serve as a resource for those that are just exiting academia and starting that horrible real life that's ahead of you, and for those that are recently new into their positions, so that we can assist in some way with making that transition a little bit easier. We have three primary programs within our NextGen committee that we're quite proud of. The first is our blog spotlight, where ideally each month we'll be taking a piece of research that any one of you might be working on and really promoting it. Through NAWI, we have access to spectacular writers, content writers, and we can serve as a resource to help with that and getting the word out, promoting you, promoting your research, and letting it be shared amongst all of your peers. We also have a fabulous mentorship program that Hannah Holmes is in charge of right now. She's on our call here as well. We're somewhat halfway through it now for this particular academic year. So I'm not sure if there's participation time right now, but we're constantly looking forward to building that up and making it bigger and better for the future. And then we have this webinar series. And within these webinar series, this was supposedly be the last one for 2025, but because of all sorts of craziness in the world, we're now over here. We're about to start taking a look at what we're going to be doing for 2026. And with that, there is a general call out for folks that are interested in becoming involved. Please consider reaching out to us. I'll drop my direct email in here. And I know that Ryan has had early on the opportunity to directly drop some links into how to reach us. So that you know, we meet monthly. Our next meeting is a week from tomorrow at 3 p.m. Eastern Time. I have an open invitation for everyone to join. If you're interested in any type of leadership roles, we'd love to put you to work. or in support roles, we're happy to do that too. With that, I am very grateful once again for all of your time. And in saying goodbye, I'd like to ask Peter to say a couple of words on behalf of what we call our mothership, which of course is NAWI itself. Peter, thanks for letting us exist. And if you can take it from here.
You bet. So everybody, thank you again for this hour and wonderful job, NextGens. And we look forward to many more conversations as, frankly, as these tools get integrated in the same way that like CAD was integrated into engineering back when we used to have blueprints. So some people remember those days. Everybody, the NAWI program continues. As you know, we are renewed for another 5 years. We have our March meeting on March 25th and 26th, this time in Phoenix, Arizona. We're tired of Denver and the snow, so we're going to Phoenix. And the Thursday 26th meeting is actually going to be an interesting one because it's actually open to the general public, to the larger water research community and water resource community. So check out our LinkedIn page. We will have the registration for that meeting coming up soon. Also, be mindful that we are now kickstarting off our webinar series. So we will have roughly monthly webinars, so don't miss it. We will have great speakers and great content as we continue to move forward as an ever-growing community, expanding the research base for advanced water treatment, water reuse, and now how that fits into regional water systems. So thank you, Ron, for all your great work on NextGen. Also, for those of you who will maybe at upcoming meetings, now we will be represented at the annual Water Reuse Symposium in mid-March in Los Angeles. So we actually have our tech showcase on Tuesday afternoon, which is about a dozen NAWI pilots. We will be at AWW ACE this year in Washington, D.C., and WEFTEC. We are currently working on proposing a session, particularly on modeling. So with that, everybody from here at NAWI World Headquarters at Lawrence Berkeley National Laboratory, thank you all very much, and we look forward to seeing you next month. Bye-bye, everybody.
Take care.
Take care, everyone.